Hello, this is Dr. B. This is a lecture on predicting products in a reaction. Specifically, it's going to be the double displacement and single displacement reactions. So when you're predicting products of replacement or displacement reactions, the key is you need to know your oxidation numbers and know your ions and recognize those, because if not, you're going to have a rough time. So single displacement, the more active element will kick off the less active element. The way that I remember it is that a metal or a cation will kick off a cation. If it's a single cation, it will kick off the cation that's in the bond or in the compound. A single anion will kick off the anion and retake its place. In a double displacement, there are two ions that will switch places. So the way that I do it is I have my cations stay in the same place, and then I flip my anions only. Remember that your compounds are either going to be plus and minus. They can't be two pluses together or nor two minuses together. You also need to keep in mind your diatomic elements. We've talked about this in class multiple times. So they are pure elements that form molecules consisting of two atoms bonded together, and there are 7 that you need to keep in mind. H2, N2, O2, F2, Cl2, I2, and Br2. We've talked about this many times in class, so you need to know these. And I'll show you examples of how these can be used correctly. So single displacement reactions. There are going to be there'll be about 5 examples that we're going to go over. This is already done, but I want you to see what's happening. So there are going to be 4 steps to consider when you're doing this. You don't have to do this, again and again and again once you get the hang of it. But for now, I want you to try to break this up into 4 steps. So the first step is going to be getting your oxidation numbers for your reactants. Number 2 would be swapping your ions, which I will show you in a bit. Step 3 would be to make your new products. And step 4 would be to balance your reaction in the end. This is already done for us, but I will just try to show you by ions what is happening. So step 1, determine your ions. Na plus, and then H2O, whenever you see that, it breaks up into H plus and, can't even see that, H plus and OH minus. Your sodium will come along because they're both positive. It will kick off the other positive ion, if you will, and take its place. So now you have Na plus and OH minus and H plus. Step 3 is determine the product. So you're going to crisscross to get your new product. It's going to be just AOH, and then H is a diatomic element, so it would be H2. And then you would balance. And you think you hopefully got it right. So the coefficients are 2, 2, 2, and then 1. Okay, we'll do these 4 steps again and again. Make sure we know what's up. All right, so I'll try to do different colors, not every time, but I'll do my best. So we have calcium plus water. Calcium's oxidation number is 2 plus. H2O breaks up into H plus and OH minus. Calcium comes along and kicks off H. So my step 2 is swapping. Ca2 plus, OH1 minus, and then H gets kicked off, so now it's by itself over here. My new products are going to be CaOH2 plus H2, and then balance. So you have to know how to get those ionic formulas and polyatomic formulas quickly. If not, you're going to struggle. My calciums are balanced. My H's are not. I have 2 on the left and 4 on the right. So I'm going to put a 2 in front of the H2O. That will distribute to the O. So now I have 2 O's. And then 1, 2, 1, 1. Zn plus Cu, Cl2. So Zn is going to be the more active element, and it will kick off the copper. So Zn, on our list, it's 2 plus. Copper can be 1 plus or 2 plus, it just depends. So if you look at Cl, automatically that is 1 minus, so your Cu has to be 2 plus. So the Zn will kick off the Cu, and your new products, we're going to be Zn 2 plus and then Cl 1 minus, and then copper will be by itself. So my first new product is Zn Cl2 plus Cu. It is not a diatomic element, so it's not going to go with 2 automatically. And it's 1, 1, 1, 1. So Br2 plus Ki. Notice now bromine is it's going to be our anion, so to speak. It's going to kick off the other anion, which is the I. So Br is 1 minus, K is 1 plus, and I is 1 minus. So Br will kick off I. Then it's going to be K plus, Br 1 minus, and then I minus. So my new products will be KBr plus I2 because it's diatomic. So then I balance. 2, 2, 1, 1. One more single displacement. So again, zinc is 2 plus. H is 1 plus. Cl is 1 minus. So the zinc will kick off the H. So I end up with Zn 2 plus, Cl 1 minus, and then H over here. So I end up with, gentlemen, zinc Cl2 plus H2. 2, 1, 1, 1. Double displacement reaction. So it's the same concept, but now your complete ions will swap places and go with another one. It's going to take another partner. Know your ions, gentlemen. If not, you're going to struggle. So I have Ag. It's usually 1 plus. NO3 is 1 minus. K is 1 plus. CrO4 2 minus. You'll notice over here on the other side, I decide to keep my cations in the same place. And then I just flip my anions, gentlemen. That's all I'm doing. So Ag now gets the gets the CrO4 2 minus, while NO3 goes with the K plus. And then you make the products and then you balance. Step 1, 2, 3, and 4. Okay, let's try it here. So potassium is K plus, iodine is I minus, Pb 2 plus, NO3. Oops, let's go. It's too dark. NO3 minus. Step 1 is getting your oxidation number. Step 2 is swapping. K plus now gets NO3 minus, and I want to keep my cations in the same place. So the only thing that's really moving is just the anions, just to make it simple for us. So KNO3 plus PbI2, and I just get that from crisscrossing the numbers. My coefficients are, I'll put a 2 here, 2 here, 1 and 1. So 2, 1, 2, 1. The way I wrote it out, that's how it is. So I get the question, does it matter what order you put the products in? No, as long as the formulas are written out correctly. So for example, you could have done PbI2 plus KNO3, and that is fine. So it's either this one up here or the one on the bottom that I just wrote in red. You cannot do this. You cannot have I2Pb, because remember, it's cation then anion. Cation then anion. Positive then negative ion. So you can't do this. You can't do Pb and K together. because no two positives. You can't do I2 and O3 together. No two negatives. Okay? So Na plus Cn minus. Ooh, that's ugly. My bad. Cn minus H plus, I don't know why I'm yelling, SO4 2 minus. So my first product is going to be, I'm going to keep my cations in the same place. So my H plus gets the Cn minus. My sodium gets SO4 2 minus. So my new products are Na2SO4 plus HCN. And I'm balanced. So I have calcium 2 plus, OH is 1 minus, H plus, Cl is 1 minus. So I'm going to do this a little quickly because I need to do another slide of more. So calcium and chlorine are now going to bond together. So we end up with CaCl, Cl2 plus. Notice my H plus and I'm going to put this down here on the bottom so you can clearly see it. H plus and OH minus end up together. That's just H2O. Okay, so keep that in mind. Put a 2 here. Put a 2 here. And that's it. So I want you to practice these. Pause the video if you need to, because I want you to make sure you understand. And then I will give you and we're going to go over how to do. We'll go over the answers in a second. Okay, so I'm going to go these through kind of quickly. So K and OH, KOH plus HBr. So the K and the Br will now partner up, and so will the H and OH. So your final products are going to be KBr and H2O. Okay, so remember your oxidation numbers. If my metal had an oxidation number of 2, that would take effect, but it doesn't here. These are all 1, 1, 1, 1. Okay. K plus B2O 3. So if you're unsure, boron, it's an oxidation number of 3 plus. K will come off and kick it off, and you kick off the B. Then you would have K2O because the O, the oxygen, has an oxidation number of, hopefully you guessed it right, 2 minus, and the B will be by itself. So we're going to end up with, put a 3 here, put a 6 there, 6, 1, 3, 2 for my oxidation numbers. Lithium plus aluminum chloride, lithium will come along and kick off the Cl. Lithium has an oxidation number of 1 plus, Cl is 1 minus. And then aluminum is by itself. I'm going to balance this. AlCl3, so I put a 3 in front of the LiCl, 3 in front of the Li, so 1 and 1 for the others. Aluminum hydroxide, AlOH3 in parentheses, or whatever, plus HBr. So aluminum and bromine are going to bond together, but you remember that aluminum has a 3 plus ion. So AlBr3 plus H and OH minus, which is H2O. Okay, put a 3 here, Put a 3 here, 1, 3, 1, 3. Lithium will kick off an H. So remember that water breaks up into H plus and OH minus. So lithium is going to come along and kick off that H plus. You end up with LiOH plus H2O. Sorry, plus H2. Wow, my bad. Plus H2. Because the H is a diatomic element. It's 2, 2, 2, 1. All right, that is it for now. It's kind of a long lecture, but it's okay. If you have any questions, please let me know. Thanks. Also, hit the like and subscribe, blah, blah, blah.